Okay, I'm going to do two video. One is for the static and code analysis demo by using the sample iauzzy as a part of the code analysis lectures practical application of the knowledge that we are going to learn. And after that, I will create another video, even though I'm recording at the same time, to do our labs. So let's start the code and static analysis demo. So we do the code and static analysis demo, and after the behavioral analysis, or sometimes we call the dynamic analysis. So based on the past four lectures, I assume you already have some idea how we do the debugging as well as the using the IDA Pro as disassembler. We want to use the actual sample iauzzy as our demonstration, so to help you to understand the detailed code analysis procedure using these reverse engineering tools. Um, of course, always internal, as we said many times, it is important. We need to use iterative and recursive approach or methodology to do our reverse engineering. So things we need to taking care. We are checking the string by basic code check, and then we sometimes we need to unpack the sample, and then we do the disassembler and then debugger. And the behavioral analysis, we already kickstart that fitnet, and we find that the sample will try to connect 6667, which is the standard port of IRC. So we based on this information, we also identify that actually once another new file called qqt.exe has been created under the system root, and actually the sample and also a registry key was updated to pointing to the QQT, even though we are running IAUSSY. And the new binary, new binary that is the QQT that is running, and IAUSSY will terminate by themselves itself. And actually, during the time, it will try to connect with different domain name with different TCP port. For example, /is/fs.org.hk is trying to connect to the standard IRC server. And in the second part of the lecture, we will be making use of this for our example to do our work. So let us first try to unpack the iauzzy, and I have already putting my sample inside the temp folder to save your time. So we are now going to put the iauzzy to and unpack the iauzzy to see what we can do. And then let me change our screen to our virtual machine. Now you can see our virtual machine. Because of time, I already have a copy of my iauzzy library here, and I don't want to show you how to do the unpack. So let us kickstart the disassembler called IDA poll. So let us first go to the start. Based from the start, usually whenever I go to the disassembler, I would like to see the core function. And by using IDA poll, usually we use the one of the function called and we move to the beginning of the functional block, such as this is start, I can right click it and go to reference, cross reference to, and cross reference from. From is on the top, to is anything below that. For here, because this is starting of the function of the iauzzy, when I click to cross reference graph two, you will see a lot of stuff right here. And there's nothing we can identify from. And from you can get a lot of the function. Whenever you see ping there, standard API call, we are not usually analyzing the API call because we can find this information from the MSDN Microsoft standard function. So right here we see we see the call argument and then we go to one of the function called at the address of 4014XC. So we click into it. If we want to go back, we hit escape and then go to double click. So we're inside here. So the same, I will go to check the call function, try to get a module handle, try to get a handle, get the process address by calling the kernel32 DLL function, and then do some zero memory thing and create file. Yes, create file is quite interesting because this is the information we want to know. And before that, it must be something pushed to the stack. But because this is only a static analysis, we are not running it right now until we put it into the debugger. So I would like to check whether the create file is interesting or not. So I better keep a record of the address of the create file A. So from here, you will see that it is the RVA is 14E8 by adding the base image base 40. So we come out 4014E8, 14E8. Hitting the spacebar change me from the text view to the graphical view. We'll go back to this call function. After create the file, we'll get the file size and the file pointer, and then read file. Yeah, interesting. Host handle. We see one malloc, which is create just like the virtual allocation a buffer. They must be keeping something in the memory and new buffer area. Once they create usually some information, we need to move to this area. So we also keep the 1530. That's important for us to consider. And then you see application and get directory, and then push something to the stack, and then call concat string cat, which is string concatenation to combine them together. A branching function right here. Both of them are calling 4012A3. Yes, seems interesting. One part is called this and then combine this, and then another part is moving something inside to this memory to EX register and also run 4012A3. Later on, we need to consider this one, and then after that, we go to comparison, and then if that is not jump, if that is 0, it will go to here. If not 0, go to here. You will see copy file. Hey, okay, it seems create the file, and then we also check some kind of registry key, and then registry key for A. So I need to mark down this address 15FC, and then after that, follow this path, you will see that it will further go into the pushing the application offset and create the registry key. And then finally, we have a lot of information after calls the registry key, a lot of information pushed to the stack, and then the application will also push to the stack, and then create a process A. So let's go back to the most important diagram I want to show you. Let me pause the recording. This is the product diagram. When we execute the iauzzy, we find that it creates a flag warning. First, it creates a file QQT in the path of system root, and then it will further create a process of QQT, and then the QQT and also will update the registry right here in the yellow one, and then after that it will continue running, and the iauzzy basically is supposed to terminate by itself. So let us go back to our debug the IDA post section. Okay, you will see that similar function when we see the static code analysis create process, there's a high chance that QQT is being called. And then after that, the function showing here is will go to another function. After doing some cleanup, it will exit process. So we hit escape, go back to the major part of these calling function. I think this is quite enough for us at this moment to see what is going on and how it is working. So in order to demonstrate this function, I will just try to put this IDA post section keep on running, and then we try to analyze the iauzzy. Hope it running smoothly. So let me minimize it. And then I see I have nothing right here. So I would like to double check the contents of my system, whether they are good or bad for further um, demonstration. Okay, we go back to our virtual machine. So I would like to analyze the iauzzy by the XDBG, X64 DBG. And actually, if we drag anything inside our system, if you put the X96 DBG, we will find a POP version of the debugger. So this is a 32-bit environment by default. It is under the control of 32 DBG. Okay, so you will see the XDBG holding the iauzzy. Now, I assume you have never touched the debugger before, or the disassembler before in preparing this demo. So I was trying to explain in more details how to use these debugger and disassembler. This is a debugger, so we can interactively see the CPU pane, and this part is the stack. This part is the CPU pane. This is the register location. Here we are using X64 DBG. We have 6 window can do the dump. So we use this dump window a bit. Whenever we license which location, it will show us on top of these message box. So we are in the ntdll.dll. So the first thing we need to go to the return to the user code. Whenever you see anything that I refer to run to the user code or return to the user code, then I will click this. Okay, we go to the starting point of the binary or entry point of this binary is 4011CB. It stopped right there. And in debugger, we can create breakpoint to make sure we are in proper situation because I have using this debugger to analyze IA users before. So let me remove them first. on your side, of course, you don't need to do so. So right now we are at the location of 4011 CB. Remember that previously we want to analyze something. Of course, we can just go through one by one. For example, this is what we call the step over. But when we step over, it just go to one by one until it hit the core function. Uh, the core function, if that is a function within this binary, then we maybe sometimes we want to drill down one another level to check what is going on right there. But usually when we're using the modern C or C++ compiled binary, use quite a lot of standard window system library. So whenever we see standard library, we usually don't care about that. Because this is the first time you see the Win debugger, the DBG 32 DBG debugger, I will try to explain and do a little bit more in details to show you. Step over is go to another instruction and then step into, for example, here we can step into. Now, whenever we step over, we see any changes in the in the register condition, something it will change into red. And the stack, if you push something and pop something from the stack, you will see the change in the stack. Right now, let us do something, for example, push EBP to the stack, then something will pull in the stack, and you will see the ESP is change, that is base pointer, and then move ESP to EBP, ESP to EBP. You will see these two change, and because it's only a move, the original value containing ESP still keep inside, and then push FFFF to the stack, and then push some content to the stack, push, and then push EAX register to the stack. So everything goes together, and we will be able to see one function called subtract ESP with the 1, 0, which means that because stack is going from top to down, whenever you see subtract, that means it in moving up. So you will see right now we are at the 169FF60. I guess it should be go to 70. Oh, it's subtract, it's go to 50. The value is also referring to the actual value, but actually it's going up and down in a different way. If we keep on going, keep on going, keep on going until we find the core. If we click if we want to analyze it, we need to enter. Then if you want to go back, I think maybe in the no, it doesn't work. So let me step one forward. So I go back to my original CPU pane to going on. Now I need to set up the breakpoint in previous IDA poll analysis. I already have some breakpoint. So I do to set up a breakpoint. I want to set up a breakpoint of address 4014E8. One thing is I go to that address. If I want to go to one particular address, I can use Control G and type 4014E8 here. Then if I want to set up a breakpoint, I can double click right here. I hit escape, it doesn't work. Let me go to another instruction. So actually you see the instruction have been changed. So when I click to the breakpoint, you see 4014E8 will be stopped at that location. So other than moving to a particular address and then double click on the or hit the function to function to set a big pond. Another is we can type a command to create a big pond. Now I want to create a big pond 401575. So you see here the message command is already being set. And then yeah, it seems okay. Maybe I create another breakpoint called BP for 015401564. So you will see 401564 create. Okay, if I go to breakpoint right here, you'll see all the breakpoint has been set up. So let me just first remove these 401464. It seems not appropriate. So I hit right click remove. I go to CPU pane. Right now, I only have two breakpoint created. So why I set the breakpoint at 401484? Let me go back to the uh, ideaple and then find the core, and you will see that one function is called the create file here. If I hit the space bar, 14E8 is the location I create. 14E8. Yeah, that is the way how I've identified the big point we need to create because I want to check what happened on that location. Another is 1575. I think maybe this one is 1575. Yes, because I may have interest to go into 4012A3 to see what is going on. Yeah, if I want to see it without using debugger, you'll see that, yeah, this is a function. This function contains a lot of, this is the beginning of the functional prologue. We'll go inside. You don't see a lot of the API code right here. Most of them is core function, except this called 0339C. If I click into it, you don't see API. I want to go back to the original calling screen, so I hit escape. So, well, I don't see a lot of things except maybe there is some function related with encryption or decryption because I see the memory allocation. But in this demo, I don't want to drill down into here. If I really want to analyze it, I will set up additional monitor function to the malloc and do the dump in the newly created buffer and keep on monitor when this modified this newly created memory buffer will put some data in and do some data change. So let me minimize it. So this is the reason why I select these 2 points. We need to doing some analysis. Of course, if I want to do something on this location, I can double click here and want to make this as one of the I want to give a comment on my I the make some comment on this location inside the X30 64 DBG. I can hit semicolon, and then I know that from the IDA pool it will call from 4012A3, and I think this is encryption or decryption. Well, that gives some information right here. Next time when you reopen it again, the comment will be loaded into the X64 DBG. So let me go back to step over actually there should be one key. I can go back to the original location without hitting step over, but I can't remember right now. So now it seems everything looks okay. Uh, how about we do a setting? Try to go to 4014E6. Yeah, I'll go to 14E6. 14E8. So 14E8. Before I want to stop here, I want to also check with 14E6 for this demo. So I have already set up the appropriate breakpoint. Let us skip the other things and we just run this application. So it stop at the 14E6. 14E6, you will see that right here. Something in EAX is pushing to the set. And from this window, we will see what actual value is right here. It seems the path of the TAM iauzzy or will be keeping in the EAX register. If I want to check the EAX register address, I can just click here, follow in dump or follow in dump A1. I want to put it in dump 1. So you will see the information contained right here. It is a pointer. The pointer is the 6, which is showing the lead to Indian. You are using the 006F1A81, which is pointing to the address of the location of 10 iauzzy. So I take away the breakpoint and step over. So here we see the create file A. So let us see whether we are actually creating a file. We open the process hacker, double click the iauzzy, go to terminal. In Windows, everything is classified as an object. Every object, if we want to manipulate it, either checking it or reading it or writing it, we may create a handle. So if we really want to create a file, see whether there's a file object created, or if we want to read anything, also may be related with this API call create file. Let us step over. Well, you see that a new file object has been created. This handle is the handle number 11C. Is the iauzzy is reading itself, try to find some information. So yeah, I think that is sufficient for this demonstration. You can see the interactive concept of the using the X64 DBG to understand the OS internal topics by checking with the process hacker information directly. So next one is I want to go to one address of one RVA of 1526. Okay, so I want to check this, so I want to just set a breakpoint here. I save the time. Why I set this? Because I want to see what happened when we calling the function called calls handle. So let me just run it. It stopped here. Nothing changed. You also see I use as a Y here. Then if I step over, you see it handle closing. You don't have a handle right here. And I don't need this breakpoint. So also there is no new process is created until the end from the ideal diagram. So next one is I want to go to 1564 or 1564, right? Yeah, 1564. I want to see the branching. 1564 is the jump not equal. Let me call back the IDA poll. that which part I want to see. This is in the 4012A3. I want to go back one item. Yeah, if I want to see the jump not zero to branching this here, the address of this instruction is at the address of the 1564. This is branching location. So we are 1564. This is reason I want to know it. Of course, I can step over, but I save the time. Yeah, here is the branching. So if the branching is true, it will go forward. The arrow will show that. If not, it just go one by one. Okay. So the point right now, I am more concerning about whether we go jump into 4012A3. Whereas 4012A3 is right here. Um, I want to stop here to see what happened. If I want to analyze them clearly in the X64 DBG, when I hit here, I will jump into. But this demonstration, I don't want to jump into. I just want to stop it here and let you see what happened there on. Actually, even though at here, you will see something interesting. In the EAX register, there's something called ABCD right here, and then do some comparison. ABCD do the comparison of branching or not branching. Yeah, if you want to drill down that, you need to redo it again from top to here and check item by item. But this demo is not that kind of purpose. I just want to show you how these function, how I apply the IDA interactively with the X64 DBG to show you how to use this tool by analyzing one function, that is iauzzy. First, it will create a file in called QQT in system root, and then update the registry, and then create a process called the QQT, and then kill itself by termination itself. So now we click here at the 4012A3 location. Nothing changed. Because I'm recording in the video, you will have time to see a little bit. We step over. What you see QQT coming out right here. So if we want to see where is the QQT located, we can do a dump in dump one. QQT is right here. Okay. But actually, where is the QQT storing? I assume, because I know this binary quite well by analyzing many times, so I can show you actually in dump2, that is some kind of variable, but that is not QQT actually, because it puts the EAX register and then calling this 4012A3. At that time, the EAX register is not QQT. QQT is the EAX register. If you watch the video, you will see that it may be putting the value one at the ECX register. And then once we push it and run it, and once after you call a function, the function returned value will be put in the EAX register as a standard. Okay, so you will see the QQT stop here. Are we coming to QQT right now? No, because we are not up to the moment to check the QQT to create a some kind of copying the file. The file is still not ready yet. If that is the case, I will be able to see the handle will be created. So let us go to here. Go to check register and you check the registry key here. It's called 8F. This one is QQT. They are different, okay? But it must be some kind of encryption and decryption operation right there. Now we go to 15D5. 15D5. Why I need to go to C15D5? Okay, it's something in pushing the QQT and then call copy file. Yeah, I want to see the copy file, but I want to stop it at the 15D5. So I set a different right here, and then I hit F9, that is 1. So you see something is process ready, keep in the registry key of 46 in the EAX register. It will trying to push to the stack. Once pushed to the stack, you'll see that's at the 10. Our 10 is keep one at the address 641881. And then at the same time, there is another file in the root of Windows root QQT.exe will be created by calling the copy file. I guess it is copying the iauzzy to the system root. Here, still we checking the process header handle table. The file has not been created, and I don't see a handle right here. So let us click step over. Okay, do we see the copy the file? Can we see the file right there? Okay, maybe I can enable it again. I don't see the window file called QQT. So maybe some more function and until we go to, we need to do it. So we pushing, a lot of stuff in the create registry key. Still, I don't see a file have been created. Maybe I skip somewhere. Maybe it create another function later. But right now, it seems that it is clear. The instruction code will create a registry key in the current window environment. Let me step over. You see the run key was coming out with the relevant handle number 174. Let us stop for a while. So we keep on running, and you will see everything will be running in a good order. So I want to skip quite a lot of function right here. I let you do it by your own self. Now I go to the address 1659. This is create a process. So I keep running. I keep right here. You will see the registry key has been closed, and everything is pushing to the registry that is QQT is going to running. So I click the set over or create process. So you will see QQT is running right now. Okay, so you will see the QQT handle also right here, suppose in somewhere location. Oh yeah, right here. Process is create. Thread is also create. So a thread is following at least one thread is running version of the process. So I want to do some other remaining things. So uh, let me go to the final step until 1659, and then go to here, and then we to go to running. And yeah, if you check capability, you will see the general that is still having the IAUs as well. So if we just click run, you will see the process we terminated. The QQT is survived, but the RAUSSY is finished. If we double check it again, you see non-existent process just shown in the OS internal lecture right there. So I keep this demo as the first section, and you guys can follow this and do it your lab at your home.